Solving equations. Solve one-step equations. To solve the equation x plus 2 equals 8, we blank the blank x by using the blank operation of addition. All right, so what is it we do? We isolate the blank x. X is an unknown value. It's a number. We just don't know what that number is. That's what an unknown value is. By using the blank operation of addition. Well, we use subtraction, which is the inverse operation of addition. So, which is subtraction. The equation x plus 2 equals 8, and the equation x plus 2 minus 2 equals 8 minus 2 are equivalent equations. And what that means is that any number we could plug in here for x that makes this equation true will also make this equation true when we plug that same number in here for x. And likewise, any number that we plug in for x that makes that equation true will also make this equation true when we plug the same number in for x there. All right, now we're going to solve for x. So as we said before, we're going to use the inverse operation of addition because we're trying to isolate or get our x value here alone. So we have to undo the operation here of addition by subtracting. So we make a 0 right here. 2 minus 2 is 0. But whatever we do on one side of the equal sign, we have to do on the other as well. On the left-hand side, this x comes down, and 8 minus 2 is equal to 6. So the solution of the equation is x equals 6. To check a solution, so we're going to see whether or not that solution is correct, we substitute. Substitute means to plug in or replace a value with another one. We substitute our answer back into the original equation and then simplify. So let's do that now. So we're going to check over here. We're going to take our original equation here, and we're going to replace the x with the answer we got for x, which is 6. So we plug 6 in for x, so we have 6 plus 2 equals 8. And now here on the left-hand side, 6 plus 2, well, that is 8. And then we just rewrite this equals 8. Right there, we just bring it down. 8 equals 8. This is a true statement. That means that the work that we did up above here to solve was accurate and correct. So we've checked our solution to that equation. All right, now when we use inverse operations while solving, oops, I'm going to need to write a little smaller. When we use inverse operations while solving, we can say we are undoing the operation. You'll hear a lot of teachers say, undo the operation, and I'll say that as well. The inverse operation pairs. So the operations that are inverses of each other are addition and subtraction. We already saw that one. Addition and subtraction, those are inverses of each other. The other inverse pair that we need to know right now is multiplication and division. Those are inverses of each other. So Division undoes multiplication, multiplication undoes division. There are more inverse pairs, but we're not going to be focusing on those right now. We'll learn those later. So let's look at these one-step equations. We are going to solve and then check our solutions. Here we have x minus 7 equals 12. So we have to do the inverse of subtracting 7, which is adding 7. So this makes a 0, and we get x is equal to 12 plus 7 is 19. Now to check, we're going to take our 19 and plug it back in for x. So we have 19, and then finish writing the rest of our equation. Minus 7 is equal to 12. Now 19 minus 7, that is 12, equals 12, and our check is good. If we came out with something like 11 equals 12, then the first thing we should do is see if we made any mistakes in our check. And then after we see, nope, our check is good, then we go back up to our original work and see if we made mistakes there. Now here we're really adding a positive 4 to x. So to isolate it or to get it by itself, we have to do the inverse operation of addition, which is subtracting. So we're going to subtract a positive 4, but whatever we do on one side, we have to do on the other. We wanted to make a 0 there, and we did, so we get x equals negative 9.5 minus 4. That is negative 13.5. If you're not sure, you can use your calculator to check. Now we're going to check our work by plugging that back into the original equation. So we have 4 plus, and because we have a negative 13.5 that we're plugging in there, I'm going to put it in parentheses because it would look weird if we did this. If we did 4 plus minus 13.5. So we want to use those parentheses there to make clear that we did a substitution. And that equals negative 9.5. Now 4 plus a negative 13.5 is in fact a negative 9.5. And then we have equals negative 9.5 on the right, and that checks. So good work so far. Here we're multiplying x by 6. Whenever we have a number right next to an unknown value, it's multiplication. So to undo multiplication, or the inverse operation of multiplication is division, some people might write it like this, divided by 6. I don't write it that way. I do a fraction. So what I've made here is a fraction, 6x over 6. Those 6's, 6 over 6 is 1, because 6 divided by 6 is 1. Whatever we do on one side, we have to do on the other. So on the left here, we have 1x, but we don't have to write the 1 in there because whenever we just have a variable by itself or an unknown value by itself, it's 1 times that. And that equals 30 divided by 6 is 5. So now we're going to check our work by plugging this back in right there. It's important that we remember that this is 6 times 5. Now, again, I use the parentheses there because we have multiplication in the original equation. So we need multiplication here as well. But if we just did 6 and then 5 right next to it, well, that would look like 65. And we don't want that. So that equals then 30, because remember, we're using the original equation here. So 6 times 5 is, in fact, 30. It equals 30 on the right-hand side there, and that check is good as well. Our last problem here, we have two different methods, or two different ways of seeing it here. Here we have x divided by 2. So it's a fraction, but fractions are really division. So the inverse operation of division is multiplication, so I'm going to multiply by 2. Whatever I do on the left, I have to do on the right. These make a 1. A 1x, so we get x is equal to 7 times 2 is 14, and on the right-hand side, and I'll use a different color here to make it clear what's happening. Here we have 1/2 times x. So when we have a fraction times an unknown value, we can take the reciprocal of the fraction and multiply it to make a 1. So we multiply by 2 over 1. So we took this original fraction and we flip-flopped the numerator and the denominator. And that makes a 1x on the left. Because when we multiply fractions, 2 times 1 is 2, over 1 times 2 is 2. So we have 2 over 2, but that's just 1. So we have to multiply by 2 over 1 on the right. So on the left, we have x is equal to, and again, remember that 2 over 1 is just the same as 2, which we had here, and so that's going to be 14. So now we can check our work. We can check it in both equations or either one. So let's check it in the first equation here on the left. So 14 divided by 2 is equal to 7. Well, 14 divided by 2 is 7. 7 does equal 7. That looks good. On the right, we have the 1/2 times the 14. Again, I'm going to put that in parentheses, equals 7. 1/2 times 14, that is 7. So we have 7 equals 7, and that checks as well. And that is solving equations, solve one-step equations.